Well, good morning from my side. I will present this talk to you, and I only have 5 minutes of speaking time, so I apologize. I can only give you a very high-level view, but if you're interested, then I'm in the poster session, so hope to see you also there. So this paper is about measuring inconsistency. Just want to give you a quick recap on what inconsistency measurement is. Basically, inconsistency measures are functions that try to quantify the severity of inconsistency in a knowledge base with a non-negative numerical value. So basically, the higher the value, the more inconsistent the knowledge base is. And a very basic baseline measure is the IMI inconsistency measure, which, for example, counts the number of minimal inconsistent subsets in a knowledge base. So we're dealing with these types of inconsistency measures, and we want to measure inconsistency in a very specific domain. This domain is business process management. So what is business process management in a nutshell? Basically, you have company processes, and we want to perform these company activities. For example, think of a loan application process. A customer hands in a loan application, and then the bank has to decide if the loan should be approved or declined. So you really can think of this that a new loan application on paper or electronically is handed in, and this loan application has all kinds of data on it. For example, customer name, customer age, all certain types of stuff you fill in. And then this loan application triggers a new process instance, and we now have to check the loan application in some step and have to decide here at this point, do we go left or do we go right, so approve it or decline it. In practice, this is not feasible in many cases to do this manually, and you want to automate as much as possible. So this automation, so to decide here how we proceed, is done by means of business rules. So you have, for example, some logical rules which tell you in certain conditions, for example, if the customer is a platinum customer, he is creditworthy, and we can approve the credit, and so on and so on. So basically, at runtime, you try to evaluate the data from the loan application against a set of business rules to make inferences. The problem is that business rules are stored in databases and created and maintained by multiple modelers over time, for example. And here can be the case that you have contradictory business rules, for example, or as in this case, we have the case that unexpected maybe customer data triggered a situation where conflicting business rules are activated. So we have one rule stating if the customer is a platinum customer, he or she is creditworthy. And we have a second rule stating that if a customer has a mental condition, he or she is not creditworthy. And then we have this maybe unexpected case that we have a customer who's both platinum but also has a mental impingement. So here in this case, we arrive in this inconsistency. So for companies, it's currently a very important task to monitor for a set of rules, to monitor if we have situations and processes where conflicting or inconsistent rules are activated at the same time because they cannot hold at the same time. And this is, if you want to audit this, it's not only related to looking at individual process instances, because we have daily maybe multiple or even thousands of process instances. So every column here is one process instance which can occur daily, and you can see that in many of these instances we have some inconsistencies. So we have basically in our setting not only individual cases but sequence of cases, and the sequence of cases is constructed over a shared rule set, and it's constructed by matching the individual fact inputs, so from the loan application, for example, with this one shared rule base. And in this setting, to support companies in auditing the inconsistency, we want to, in our paper, develop new means for analyzing inconsistency over these sequences of cases, not only in single cases. For example, questions you can have here is, if you're looking at the entire sequence, then what are the distinct inconsistencies that occurred? And also you can think about what rules are responsible. So for example, you can see here this rule marked in red is part of all inconsistencies over all cases. So this would be a good starting point for remodeling or for debugging these inconsistencies. So what's in the paper? As mentioned, the existing literature focuses more on measures for individual cases, and in this paper we introduced measures for the sequences of cases, and we showed a method how existing inconsistency measures can be used to induce these multiset measures. And in this context, we also showed that our method of inducing these multiset measures, if you induce it this way, then these measures still maintain important desirable properties of inconsistency measurement. And we also examined then complexity aspects regarding inconsistency measured in these sequences of cases. So yeah, I thank you very much for your attention. Maybe you have a question now, or otherwise we'll see you together, and thank you for the attention.